The next principle is interface segregation principle. This states clients should not be forced to depend on methods they do not use. This principle applies to interfaces. When you create an interface, the clients will depend on that interface. And if an interface contains too many methods, then it will become too complex to use. And in that case, it's called a fat interface. A fat interface provides too many methods, and some clients may not use all the methods, but they will still be forced to depend on them. So in this case, we can segregate the interfaces, and each interface will be used by just one kind of client. This is an example of an interface called iFile, and it provides two methods, read and write. Now, not all clients may want to use both the functionalities at once. Most of them would probably want to read or write. So this interface is a fat interface. Even though one of the clients may only want to read, it will be forced to depend on the write method as well. So we will apply the interface segregation principle and segregate the interfaces like this. iRead will provide the behavior for read functionality, and iWrite will provide the behavior for write functionality. Now the clients are not forced to depend on methods they do not use. The last principle is the dependency inversion principle. It states abstractions should not depend on details. Details should depend on abstractions. In simple words, it means program to interface, not to implementation. So here, abstraction means an interface and details mean the concrete classes. If you use a concrete class directly, then it creates a dependency and coupling with that class. And in future, if you want to use a different concrete class, then you have to modify existing code. And this again violates the open-closed principle. So instead of making your code dependent on the concrete class, let the concrete classes depend on your code. So this way, the dependency is inverted. That is why this is called dependency inversion principle. In this example, there is a hierarchy of image classes. The base class ImageReader provides a behavior through which an image can be decoded. And we have added a class called bitmapReader. And this class can read the bitmaps from the disk, and then that data can be displayed on the screen. The image data is displayed through this class called ImageViewer. And this ImageViewer uses the bitmapReader and displays it on the screen. But in this case, it gets tightly coupled with the bitmapReader class. In future, in this hierarchy, if more image readers are added, then you will not be able to use them easily in ImageViewer. You will have to modify this class to add support for more readers. So this violates dependency inversion principle and also the open-closed principle. Because the bitmapReader is dependent on the concrete class and not the abstraction of the bitmapReader. The abstraction of the bitmapReader is ImageReader. BitmapReader is a specific abstraction. So instead of depending on a specific abstraction, you depend on a general abstraction, that is the ImageReader. So let's invert the dependency. Now ImageViewer will depend on ImageReader. So at runtime, we can set an instance of a reader, and then ImageViewer can use that reader to load an image and display it. So this way, we are now programming to interface rather than implementation. So for ImageViewer, ImageReader is a dependency. But you need an instance of one of the image readers that can be used by ImageViewer. So you need to inject that into ImageViewer. Now there are different ways of doing that, and this whole process is called as dependency injection. And there are various ways of injecting the dependency. But in our case, using dependency inversion principle, we have reduced the dependency on specific reader classes.
I hope you have understood S.O.L.I.D principles. I will refer to these principles again and again while explaining different kinds of design patterns. Thanks for watching. I'll see you later. Goodbye.